So, Hall effect. So in this video we discuss about the Hall effect. So first of all, you need to think about it. That is, if you have the semiconductor, then you need to know it is a N type or it is a P type. How did you know that? That is the semiconductor is N type or P type. So the solution is Hall effect. So by the Hall effect, you can easily measure or easily check that the semiconductor is N type or P type. So this is the main basic things of Hall effect. Now, how did you find that? Let's discuss. Now, if a metal or semiconductor are carrying a current I placed in a transverse magnetic field, that means if it is a y-axis, this is x-axis, and this is z-axis, then if a specimen carrying a current placed in a transverse electric field, that is, the electric field is conducting B, let's B electric field, and according to Z axis, now the semiconductor are placed here as like that. So this is the semiconductor bar, you can write here. So this is the semiconductor are placed in x axis, and in y axis, this is y axis. So now the semiconductor current carrying, that is I. This carry I. So the width of the semiconductor, let's W, and height is D. So according to the Hall effect, or before Hall effect, the main function is that the electric field for I current according to x-axis, direction to x-axis, and magnetic field, that is B, is in z-axis, then electric field are induced in y-axis. That is, electric field are induced, that is E, induced in y-axis. So for perpendicular to both I and Z, or I or B, that is X or Z perpendicular, the electric field are directed. So that is electric field E. So now this phenomenon is known as Hall effect. It is used to determine whether a semiconductor is N type or P type, and find the carrier concentration, that is N and P value. Carrier concentration find, we can find the carrier concentration by also Hall effect, and also by simultaneously measuring the conductivity, that is sigma, we can measure sigma, and the mobility. So this value we can get by the Hall effect of a semiconductor. Now in this picture we gave, that is the whole illustration. Now what it means, that is, in steady state the magnetic field force, that is the force of magnetic field, that is Fm, equals to force of electric field in steady state. We are concluded that now what is the value of Fe? Fe means the field according for the electric field. The value of is this Q, that means charge, into the electric field E, equals to the magnetic field. The value of magnetic field is B into Q into V. This is the formula for magnetism, that is the magnetic field formula is B Q V, and for electric field this is formula QE. So if both are equal, then we can get, that is Q is the charge obviously, and V is the voltage. Now in surface 1 and 2, that is 1 and 2, if we suppose this surface are inducing some voltage, so this voltage is known as Hall voltage. So what is Hall voltage? Hall voltage are induced in the surface of the semiconductor metal. So that's why we get the Hall voltage. Now from this equation, the derivative of Hall effect are come, that is Q is the charge, here written that Q, charge of the carrier, V is the drift speed. V, what is V? V is drift speed. So now we know that is, what is E? if we E, what is the value of E? Electric field, we know that is electric field is Hall voltage, that is voltage by distance, that is Hall voltage, here induced Hall voltage by distance d. The value of electric field equals to Hall voltage by d. And now, so if Q or cross it out, in this equation this becomes E equals to B into V. Now put the value of E, that is VH by D, from this equation equals to B into V. This is Hall voltage and drift speed, and B is the magnitude of magnetic field, and D is the distance of the bar, that is D of the thickness. So this is the distance between surface 1 and 2. The surface 1 and 2, the distance between surface 1 and 2 is D. So that's why in both surface, parallelly both surface are for depend on the voltage. So electric field VH by D. So VH by D equals to V into V. So from this equation. So now VH, now we know that this is another equation pointed out. Then what? Then after we know that there is the current density, that is J equals to what? J equals to I by area, that is current by cross-sectional area, equals to rho into V. What is so here rho is the charge density into V, that is the drift speed. So rho into V, that is the J. So if VH by D, so what is the value of V comes from here? We get that is drift speed, that is small v equals to I by rho into A. So small v comes, that is I by rho into A. So if what is A? A is actually area. So width into distance, that is I by rho into distance d and width w. So if we substitute the value of v into equation 1, then what it comes? So it comes, that is VH by D, that is VH by D equals to V into V. So if we put the value of B into V, so it becomes VH by D equals to B into I by rho into D into W. So D cancel out. Then the value of VH, that is Hall voltage, becomes BI by rho into W. This is important concept or important equation you pointed out, that is VH, that is Hall voltage. What Hall voltage? Magnetic field into current by rho, that is charge density, into width. So now the value of Hall coefficient, that is RH. RH is the value of Hall coefficient, RH. So RH equals to, obviously, that is resistance, that is 1 by rho. So the value 1 by rho is, so from here we get that is rho equals to W into VH by B into I. So what is by 1 by rho? That is BI W into VH. So this is the value of Hall coefficient RH. Now if we finding the conductivities, that is mu, the formula is mu equals to sigma into RH. This is very important. All equations are important. You point it out. That is the Hall coefficient, Hall voltage, mobility, drift speed, and previous we have done, that is electric field and magnetic field value, and overall current density we can get or calculate it. So by this we can get the value. After value of finding mu, we can easily calculate the value of mu, that is it is n type or p type. and for Hall voltage and resistance we get the value. So we can conclude that the semiconductor is either N type or P type. So some important concept, that is usefulness Hall effect. Let's discuss what are the usefulness of Hall effect. So the usefulness of Hall effect is that point one, that is Hall effect, and by Hall effect, so by Hall effect we can get the value, that is we can conclude that is the either it is P type or N type. Either the semiconductor is P type or N type. So this is the first point. The second point is it is used to measure majority carrier concentration, that is carrier concentration, and it is used to measure the majority carrier mobility, that is mu. This is the usefulness of Hall effect. Now applications. What are the application of Hall effect? That is magnetophyte meter is an instrument operating in the principle of Hall effect. That is magnetophyte. In magnetophyte, magnetophyed, magnetophyte is an instrument is used by using the Hall effect, which uses the Hall effect to measure the magnetic flux density, that is B. Another instance, the Hall effect is also used in Hall effect multiplier. It gives an output proportional to the product of two signals. So these are the main concept of Hall effect, and in this video we ended with the Hall effect.